All right. In today's lesson, again, we're looking to solve rational equations. And now would be a good time for us to look at some keywords in today's lesson. And perhaps because we're solving rational equations, we're going to need to know what rational numbers are. And we have some examples of rational numbers right here. 3 is a rational number. 3 ones is a rational number, and so is 0.25 and 1/4 is a rational number. And we might wonder, well, what makes a number rational? How is it, say, different than other numbers? Let's say we have numbers 1, 2, 3, and we continue counting 4, 5, 6. Aren't, how is that different from these numbers? Well, actually, these are rational numbers, but there are other numbers that don't follow this pattern that are rational. For instance, 1/4 wouldn't be a part of a counting number. Like we don't say 1, 2, 3, 1/4. We'd say 1, 2, 3, 4. But 1/4 is actually a rational number, and that helps us give us a clue as to what is special about rational numbers. Is rational numbers, actually, let me not, rational numbers, these numbers uh, can be made into, oops, made into fractions, okay? This 3 can be made into 3 ones. That's a fraction. 0.25 can be made into a fraction what happens to be 1/4. So rational numbers can be made into fractions. Okay. Now let's look at the next set of information here. And next keyword. And we're looking at opposite numbers. We have negative right here, negative 0.25. Sorry about that. Negative 0.25. And we have positive 0.25. And if we added these numbers together, negative 0.25 plus positive 0.25, well, we would end up with 0. So those numbers are said to be opposites. And similarly, if we had plus 10 and we added a negative 10, since these have the same value, they're both 10, and they have the opposite sign or opposite direction, so one's positive, one's negative, then positive 10 added to a negative 10 is going to also be 0. So again, we have opposite numbers. When you actually, we'll pause the video for a moment and tell me what you think the definition of these opposite numbers is going to be. Okay, hopefully you've got a moment to collect yourself and to write down what you think the definition is, and now I can check to see if that matches with mine. Um, well, we're going to say opposite numbers. Opposite numbers are numbers that add to zero, or maybe say their sum is zero. Their sum is zero. Okay, so we've talked about rational numbers. Rational numbers can be made into fractions, and opposite numbers, numbers that add to zero. And let's look at the last key word that we want to look at here. Let me change this a little bit. Let's try to change it. That. There we go. And now we have our last term, and this is a reciprocal, or some might say the multiplicative inverse. All right. And we have some examples here, and some examples are 5 over 10 or 2. And somehow they are reciprocals of each other, or multiplicative inverses. And then we also have 3 over 1 and 1 over 3. Can you guess why these are multiplicative inverses or reciprocals? What about them makes them so? Pause the video for a moment and then write your thoughts down, and then I'll share mine, and you can compare to see if yours matches mine, and we can compare. Okay, well, why might we call these reciprocals is because if we multiply these two together, 5 5/10 and 2, this is the same as 2 over 1, we multiply them together, we would end up with 5 times 2, 5 times 2 over 10 times 1. And that would be equal to 10 over 10. And 10 over 10 is equal to 1. Well, what do you think is going to happen with when you multiply 3 over 1 times 1 over 3? Well, that's going to be equal to 3 times 1, 3 times 1 over 1, 1 times 3, which is going to be equal to 3 over 3, and that equals 1. So pause the video again and tell me what you think the definition is of these reciprocals or the multiplicative inverses. Okay, well, hopefully you've paused the video and come up with your own conclusions, and you can compare how it matches with mine. So these reciprocals or multiplicative inverses are numbers that multiply to equal 1. Or I should say two numbers that multiply to equal 1. So here we had 5/10 times 2, or 2 over 1, and we ended up with 1. Or we had 3 over 1 times 1/3, and that ended up being equal to 1. We'll continue working on our solving rational equations, given that we've got now a background to recognize opposite numbers and reciprocals or multiplicative inverses. And that's going to help us to solve equations with rational numbers.